Good day and welcome to this episode of Applied Electricity. In this episode, we are going to be calculating voltages and current using the Thevenin theorem. You are familiar with Thevenin's theorem. The theorem states that for any linear electrical network seen from two terminals, so they can be represented by a single voltage source in series with a single resistance. So that's what we are going to be doing here. So it has steps. The Thevenin theorem has different steps. As you can see here, we are asked to look for the voltage. In this case, the voltage across this 200 resistor using the Thevenin's theorem. In another question, they can ask you to look for the current. So that is why in this video I'm going to be dividing it into two. So we'll do one for voltage and we'll do one for current. They have their respective formulas. So without wasting much of our time, let us get going. So this is the circuit diagram we are given. This in parallel with this, in series with this is also in series with this, and we have the load resistor. So now our first step is to remove the load resistor. We are going to remove this load resistor away, and we are going to short circuit the source. This is the source here, the voltage source. So we are going to short circuit this, and we are going to remove this away, the load resistor away, so that we can get our Thevenin. That means the Thevenin resistance. So what am I saying? When we do that, we are going to be having something like, when we remove this voltage source away, we are going to be having something like this. So now I'm going to calculate the Thevenin resistance. So what are we going to be having? This Thevenin resistance is just the calculation of all the resistance either in series or in parallel. Let us study them one after the other. This is in parallel with this, right? So we write it 600 in parallel with 600. So looking at it also, you see that this is in series with this. Remember I told you this is out already, that's why I have to redraw it here. So this is in series with this, and when this is resolved together, it becomes parallel to this part. So that means this also will be parallel to the series of this and this. That is 300 plus 300. So it will be, this one will be 600 like that. So when we get the parallel for this one, we now do it in parallel with this. So let's start from here. We have 600 multiplied by 600 divided by 600 plus 600. So this will give us 300 ohms for this part only. So then we can now use it in parallel with this. When you use this one in parallel with this, I'm going to be having 300 in parallel with 300 plus 300 is what? 600. Do you get? So when we do this now, we are going to be having 300 multiplied by 600 over 300 plus 600. So what are we going to be having there? When we solve that, we are going to be having 200 ohms. So this is the Thevenin resistance. This is the Thevenin resistance. So now we've gotten the Thevenin resistance. That's the first part. We're also going to get the voltage, Thevenin voltage. So the VTH. And how do we do that? We are going to put back that source that we short circuited away. This 10V. Now we're going to replace it back there, and we are going to leave this place open circuited. What is open circuited? This means that there will just be 2 points here. This one will be eliminated. You know, we never had it before. So any current that flow through this place downward is not counted as current. It's not counted as any resistance functioning. You only face the functioning resistances. So when we do that, we are going to be calculating the another equivalent resistance. So what will that one be? It will just include 1, 2, and 3 for the equivalent resistance. Why? Because the current flowing through here, when this one is coming here, is already going to the ground level, so it's not flowing to anywhere. There's no current flowing through this. So we are dealing with the one that current is flowing through. So let's move. So to get VTH, what are we going to do? We are going to look for we need IR, right, to get V. So we want to get our R first. Let's get our R first. So R equivalent will be equals to this. Both of these, they are still in parallel. We've calculated it here before, which is 300. So we have 300 ohms. So after that 300 ohms, we have another 300 in series with this now. Since we have eliminated this, in series with these parallel ones. So we have 300 plus 300. 300 plus 300 will give us what? 600. It's just step by step, one after the other. There's nothing difficult there. So now we've gotten our resistance. We need also the current. And how do we get current? Current is voltage divided by the resistance. So it's going to be voltage divided by the resistance, and we already have the resistance here. So just see current is equals to V over R equivalent. So that will be 10 over 600. 10 over 600, that's 0.0167 ampere. Now we are now going to calculate the R Thevenin. I want to chip in something. Remember I said we open circuited this place. This place that we open circuited will stand as the V Thevenin. Anywhere we open circuit will be our V Thevenin. So now we want to check our V Thevenin now. Our Thevenin voltage is going to be I multiplied by the equivalent resistance. And what is going to be our equivalent resistance? And that's, it's not even equivalent because it's just resistance. So we are dealing with only the resistance that is in this part. We get. So now we are going to be having I, which is this 0.0167 multiplied by the V Thevenin is here. So what is the resistance in action in this place? This one we know we've taken away 200 here. We are dealing with this 300 here. So we are going to be having 300 for that. And when you calculate that, you are going to be having 5.01. So that's 5.01 voltage. So now we have our V Thevenin, we have our R Thevenin. So we can get, and we also have our load resistor. So we can get the voltage that we are asked to look for. So when you are looking for voltage, I think we should write out our given. So let us write all what we have gotten so far. R Thevenin is what? 200. Our load resistor 2. Our RL is also what? 200. Then our V Thevenin. Our V Thevenin is 5.01 voltage. So now the formula we used to get that. Remember, we are looking for voltage, and normal formula for voltage is I over RM. Voltage is equals to IR, right? But in this case, when you are calculating under Thevenin, you are going to be seeing the voltage that you are asked to look for is equals to the voltage Thevenin multiplied by the load resistance over the sum of both resistance, both the Thevenin resistance and the load resistance. That is the formula you are going to use. It wants to look like plus, not multiplication. It wants to look like something in parallel. So that's the formula they normally use. So you have V equals to our voltage Thevenin is 5.01 multiplied by our RL is what? 200 over RTH is what? 200 plus 200. So let's calculate that on our calculator. We are going to be having 2.50 voltage. So this is the voltage we are asked to look for. This is just the first part, and we are going to be moving to the second part. In this part, we are going to be calculating. In that second part, we are going to be calculating the currents. So this is the second part that we are going to be calculating, and as you can see, we are asked to find the current in the 20 ohm resistor using Thevenin's theorem. Very, very simple, as we've been doing. So first step, you always remove your RA. And where's the RA? This is it here. What is RA? The load resistor. When you remove the load resistor, you are going to short circuit the source. And looking at this one now, we have two sources here. We are going to short circuit it. Let's see what we have. So here we have, so this is what we have. This is this 10 here, this 15 here. This has been short circuited, that's why there's nothing there again. So this also I told you I'm going to remove the load resistor. There's no more there also. So 5, this is it here, 10, this is it here. Then this has been short circuited. So now we name the points A, B, and this ground, let it serve as C. So now, when we did it the other time, we also calculated the Thevenin resistance. Now also we are calculating the Thevenin resistance, and it's very, very simple if you are going to flow with it. Look at this now. This is in series with this. This is also in series with this. But when they join together, they will not become parallel to each other. So that means that 10 plus 15 is in parallel to 10 plus 5, right? So we are going to be having 10 plus 15. They are in series. So in parallel with, open bracket, 10 plus 5. You get that, right? So 10 plus 15 is what? 25 in parallel with 15. So we can just do that. 25 multiplied by 15 over 25 plus 15. Let's calculate that. We're going to be having 9.375. 9.375 resistance. So that is the R Thevenin. That is the Thevenin resistance. Now we've gotten our Thevenin resistance, and remember we also need voltage Thevenin. We need the Thevenin voltage. So what are we doing from there? To get voltage Thevenin, we are going to say it's like as if we are looking for this place here, VAB. So let me just say, this is the bridge. This is the bridge between this side and this side. And I told you, anywhere that we open circuit, we serve as our V Thevenin. That's what we did last time. So this place is the V Thevenin that we are looking for. So we say that V Thevenin is equals to VAB. And so now we will now need the voltage here and the voltage here before we can get AB. So from that view, we are going to be having the current I and the current A and the current B. So how do we get that? Current A is equals to the voltage over the equivalent resistance. That means here there's an equivalent resistance in this place and there's an equivalent resistance in this place. We are going to be using the current over the current we got, the current over the equivalent resistance. So what am I saying here? To calculate for IA, you have V over R on this side. Remember there is a 30 volts here and there's 15 volts here. That's the voltage that we're using to get our current here. So we're going to be having on this first side, we're going to be having 30 over, what's the resistance here? They are in series. So it's going to be 10 plus 15. And IB2 on the second side, we are going to be having V over R equivalent to, that's 15 over this. So 15 over 10 plus 5. This will give us our IA is 1.2 ampere. So this is 15 over 15. This will be 1 ampere. Now we have both IA and IB, the current on this side and the current on this side. So what are we doing next? We are calculating the voltage on this side and the voltage on this side. You all know that very well. So it's going to be V for A, V for AB, AC, and V for BC. So let's say for AC now, I said we represented the ground level as C. So V for AC now will be I 1.2, I for A 1.2 multiplied by the resistance in this VMAB, AC rather. This is the resistance here, and what is that? That's 15. So for VBC2, it's going to be the current, which is 1, multiplied by the resistance there, which is 10. This one will give us 10 volts. This will give us, in our calculator, 18 volts. So that will give us 18 volts. So now we've gotten VAC and VCB and VBC, or either way. So now the subtraction of these two will give us this AB. It is in the middle, right? And we have this. So the subtraction of both of them will give us the V Thevenin, which is also the VAB. So V Thevenin will be equals to 18 volts minus 10 volts. That is what? 8 volts. That is our V Thevenin. So now we've gotten our Thevenin, but now we're looking for the current. So current, when you're calculating for current in this case, let's write our what we've gotten so far. So our Thevenin is what in the question? Our Thevenin is 9. One we got 735 point, and our Thevenin is what 8. Our load resistor is 20 ohms here. So now using the formula, I will just say I naught. You know the formula for I is V over R, right? But now it will be V Thevenin over the sum of the resistance. So RL plus R Thevenin. Yes, so that's it. What is just remaining now is just to insert the given, well, what we got in the question rather. So now it will be 8 over R, the load resistor will be what, 20 plus the R Thevenin 8. So that will give us approximately, on our calculator it's going to give us 0.27 ampere. So that is the current we are asked to look for. So I think with this we are good to go. So you can drop questions that we need to solve that you feel that you can drop if you don't understand very well, so we can solve. We are still going to be doing videos on superposition theorem also in this episode. Thank you very much. Like, share, comment, and subscribe. So this is the end of the video.